Hey everybody, it's Mr. Veve again, and this is just a little bit of help with balancing these equations. So I know you can't see me, and it's probably kind of weird for you, but just bear with me, and we're going to learn how to balance some equations. I'll show you a couple of tricks here. Okay, so and also bear with me because I'm going to be probably writing a little bit like a third grader here with this pen. All right, so what we got here is we've got zinc plus nickel 3 nitrate gives us zinc nitrate and nickel. And if you thought this is a single replacement reaction, you'd be absolutely correct. So let's actually balance this because we can see that it is not balanced. All right. So the first thing I like to do is I like to find the arrow right in the middle, and I like to list every single element that is involved in the entire reaction here. So let's go ahead and see. We've got zinc, we've got nickel, and we've also got nitrogen and oxygen, but look, it's in nitrate form over here, and also on the right side it is still nitrate. So it's a little shortcut that you can do when you have these polyatomic ions. You can list them as the polyatomic ion. Saves you a little bit of time, only if the polyatomic is intact on both sides. Okay, now what I'm going to do is I'm going to put dashes on either side of either of these. Okay, now we can keep track how many of each we have on the left and the right of the equation. So first thing we're going to do, count how many we have. So how many zincs on the left? 1. How many on the right? 1 also. How many nickels? 1 nickel. 1 nickel over here. Now how many nitrates? In O3 we have 3 of them on the left hand side, and we have 2 of them over here on the right hand side. Now the only thing that's not balanced is those nitrates. So what we need to do is we need to balance them. Unfortunately, I can't just add 1 more to the right hand side. It doesn't work that way. When we change these coefficients, it's actually multiplying and distributing here. So what we have to do is find the least common multiple of 2 and 3. So the number that 2 and 3 have in common, if you count by 2's and count by 3's, is 6. Okay, so how do I make it look like I have 6 nitrates over here? Well, I'm going to have to multiply this whole thing by 2. Okay, so 2 times 3 nitrates, I now have 6 nitrates. Okay? And then multiply this one by 3. That is an awful looking 3. 3 times 2 gives me 6 nitrates over here. But if you noticed, I put this 2 coefficient here. That distributes not only to the nitrate, but also to the nickel. So now I have 2 nickels over here, and I actually have 3 zincs over here. It's very important as you go and you change these coefficients that you actually keep track and count everything. So now look, nitrates are balanced, but zincs and nickels are not balanced. Okay, let's look at zincs first. There's 3 over here and there's 1 over here. I need 3 zincs on this side. How do I do that? Well, multiply this 1 zinc by 3. 3 times 1 gives me 3 zincs. If you guys notice, I'm just crossing out how many I had and putting my new total over here. Okay, so now I have 2 nickels on this side. I need 2 nickels on that side. 2 times 1 gives me 2. 3 and 3, 2 and 2, 6 and 6. All seems to be good, right? Okay, so we've got the next problem here. We've got acetylene, and this is going to be combusted, and we're going to get carbon dioxide and water. So let's balance this one now. So bear with me while I get my pen ready. And the first thing we're going to do is we're going to list the elements involved in this reaction. Carbon, hydrogen, and oxygen. Wow. My penmanship is awful. Okay, let's count up how many carbons we have on the left and the right. So on the left-hand side, we have 2 carbons. On the right-hand side, we have 1 carbon. Hydrogens, we have 4. And then we have 2. Oxygens, we have 2 on the left, and we have 2 up and 3 on the right. Very important in combustion problems. Don't remember, your oxygens are split up. Okay, always be aware of that sort of stuff. All right, so what's not balanced? Well, nothing's balanced. But the easiest thing to start with is going to be your carbons. So let's start with carbons. I have 2 on the left. I need at least 2 on the right. 2 times 1 is 2 carbons. And now this also changes the oxygens. 2 times 2 is 4 oxygens, plus another 1 gives me 5. Okay? So now carbons are balanced. Hydrogens and oxygens are not balanced. Oxygens are kind of a big mess. I always recommend going with hydrogens next. Okay? It's going to be a little bit easier that way, and you save yourself a lot of headache. So I have 4 hydrogens, on the left. I need 4 on the right. So what times 2 gives me 4? All right, 2. 2 times 2 is 4 hydrogens. This also changes the oxygens. This is 2 times 1 is 2 oxygens, plus 2 times 2, which is 4. 4 plus 2 gives me 6 oxygens. All right? Carbons and hydrogens are good, right? Just oxygens left. 6 on the right and only 2 on the left. Well, what times 2 gives me 6? Well, in this case, 3. And in all cases, actually, 3 times 2 gives you 6. Okay? So that is now 6 oxygens. 2 and 2, 4 and 4, 6 and 6. Seems to be good. And remember, look, there's nothing here, so that's just really understood to be a 1. So this should be a balanced combustion equation. Hope this helps you guys out a little bit when you're trying to balance these equations. So good luck.